So, welcome everyone. So, this is a talk on the Ascent Forum, which is a forum for looking at science and spirituality together. And today we have a very interesting talk from Pranav, who is from Princeton University, who is doing his PhD in solid state physics. And this talk is about reality and whether there's reality or not. So I invite Pranav to introduce the talk and subject and start. Welcome, Pranav.
Thanks for the introduction. Can I share the screen?
Yes, please.
Okay. Okay. I'll start.
Yeah, go ahead.
Okay. Hi, everyone. Welcome to another talk on the Ascent Forum. And today I will talk on this topic, illusion or reality. So before I start this talk, I just want to say I'm not going to conclude anything, but what I will do is I'll give you some nice examples of what we see in physics, and then you guys can conclude if anything is real or if anything is illusion. So let's start. So this topic of whether the world that we see around is really the world as it should be? Is it the reality that we are seeing when we see something, when we touch something, when we hear something? Is that how nature really is, or are we missing out on a lot of things? Is it actually real? So these kind of questions has plagued mankind for a very long time. And there have been several philosophers across various in various places who have questioned this, and they have drawn their conclusions about what this world is. So I'm just going to give you a few examples here. So these are Greek philosophers, Socrates and Plato. And to Socrates, so for him, anything that he feels, that he knows through the sense organs is apparently an illusion, because what we gain from our sense organs is a very limited amount of information, and the true world that he says, the real world, is actually invisible to us, but it is where all these forms exist, is what Socrates says. And similarly, Socrates' student, Plato, also has these kind of philosophies, and he has this analogy over here. It's called Plato's cave. So he feels, essentially it's like there is this prisoner who's stuck in a cave, and all he's able to see is into the cave, into the darkness. And behind there is light, and he sees some shapes. And now Socrates, and now this prisoner assumes whatever he sees as shapes is actually the real thing, but in fact it's only some shadow that's coming because of the light. So this is how he assumes the real world also works. All we see are some remnants, some shadows of reality, and we are actually never going to perceive reality. Coming to Eastern philosophies, like for example Vedanta, these kind of statements have existed throughout, starting from Shankaracharya. He says Brahma Satyam Jagat Mithya, and all the way to contemporary philosophers, like for example Vivekananda and Dayananda Saraswati, who say like world is Maya, and so on and so forth. Now, if you take away the philosophical aspect, people have even portrayed such ideas in movies. For example, there is this one very nice movie in English. It's called The Matrix. And the idea in this movie is that all of us are living in a simulated reality. So whatever we perceive, which feels extremely real, is actually some sort of a very advanced simulated reality. And what we are perceiving is actually, so what we are perceiving is not actually what we think we are perceiving, is just nerve impulses that have been generated, neuron impulses that have been generated in our brain, and we feel that the world is extremely real. So these are some of the ideas that have existed. So these are ideas essentially and philosophies that have existed where people say that the world is unreal and the world is elusive and so on and so forth. But is there something that science can say about this? Can we actually use physics to try and understand some of these concepts, to try and understand some of these philosophies through a perspective of science, is what I'm going to discuss briefly here. So I'm just going to talk about one particular topic, and I'll make sure that I don't use a lot of jargon and stuff. I'll try to keep things as minimalistic as possible. So in case if you find that I am delving too much into the physics, please stop me, and then we can see from there what we can discuss further. So it's all thanks to this person over here, Ludwig Boltzmann. So he's a scientist who contributed significantly to these two fields, thermodynamics and statistical physics. Don't worry about the formulas over there. It's not. I'm not going to discuss any of that. Please don't be scared. But it's because of this one person's revolutionary ideas that physics has grown so much today. And thermodynamics and statistical physics is like one of the most fundamental pillars of physics that we have. If you want to understand any of these subjects, including condensed matter physics, you need to know what thermodynamics is and you need to know what statistical physics is. So the problem that I'm going to address is one of these neat, I wouldn't say absurdities, but one of the neat intricacies that comes up because of an direct application of thermodynamics and statistical physics to the real world. So let's see what happens. So in thermodynamics, there is this principle called entropy. So essentially what it says is that the universe loves randomness. So it's very hard to constrain the universe. So I like to think of it as universe is like a small child who goes around creating disturbance and creating a ruckus all the time. And every time you want to constrain the child, you have to use a lot of energy, because a child is always so energetic. You have to use a lot of energy to come and constrain it. So the universe is also like that. So if you want to constrain the universe and get some work done, you need to put in a lot of energy. The universe by itself prefers a lot of randomness. So one simple example over here is this. So you take a glass and then let's say let's say you just dropped it. So it breaks, right? So this is an easy process. Breaking a glass piece is an easy process. Now the hard part is putting the glass back and making it into the old glass. So you need to do a lot of things for that. I don't know, put around some tape, but then that wouldn't restore it to its complete pristine nature, because there will be cracks. So then you will have to heat it up, make it even, and so on and so forth. and it's a very hard task to put the glass back. It's very easy to break it. So universe is also like this. It loves randomness. It wants to get as disordered as possible, but trying to put things back together in the universe is exactly this part of the process. That's why it's very easy to break things in life. It's very hard to put things back together. So this is part of what we call as the second law of thermodynamics. It essentially says that randomness in this universe is ever increasing with time, and the universe always prefers randomness. Now, what can we do with this though? So, over here, I'm going to share. I'm going to share something, but it turns out you can ask a question. So the universe is always getting so random. But at some point, can there arise some order just because of this randomness being too random? Can it eventually come to some order at some instant in time? So this is what we are looking at. So I'm going to play a video here. So it essentially is this. I don't know if you guys have seen this, but if you take old video boxes and you pause it, there is this tiny logo that keeps bouncing off the walls, right? And what everybody likes to see is if this tiny box over here goes and hits right at this corner. So most of the times it doesn't. It also seems like the box is doing hitting at some random positions like this. But then what if you waited? So you wait for a long time, and eventually the box is going to land right at the corner like this. So it seems as though things are randomly hitting all these sites, but then you wait for a very long time, and suddenly it will go and hit this corner, and that's sort of some order happening. So it turns out when you do, or when you follow this Boltzmann's theory and you follow all of these, the universe also behaves this way. You take a random collection of objects. All it wants to do is it wants to be as random as possible. But at one particular instant in time, if you wait for a very long time, they can all spontaneously come to one position like this. They can all get into a highly ordered state as well. So there is a possibility for something that is totally random like this to come and spontaneously form some kind of an order this way. But for this to happen, for example, in the universe, you need to wait a really long time, which is like greater than the age of the universe itself. So it's not practical from a human point of view to observe this, which is why like you never see a broken glass. So there is a tiny probability for a broken glass to get reordered into a complete glass simultaneously as well. But the time that you need to look and wait and observe, just like this TV thing that I just showed you, is that it would be an enormous amount of time, much greater than the human lifetime, which is why you never see like a glass spontaneously coming back to its original state. So can we really have order from randomness? It is possible. So then how much order can there be? So can you have like a glass spontaneously coming up? Yes. So then can you think of something more? Maybe like human organs coming up spontaneously. What is the chance that the atoms today of the universe spontaneously come together and simultaneously form this so-called organ called heart, or for example over here a brain? Yes, that is possible. What is the chance that it comes and forms Ludwig Boltzmann? Yes, that is also possible. So scientists took this idea one step further, and they invented this so-called notion of what is called as a Boltzmann brain. So the idea over here is that all the atoms in the universe, they come together so the atoms in the universe, they come together, and at one instant in time they form a brain, but this brain is a special brain. So this brain has all the memories of what a human experiences. So it has all the identities, and it also has, like, for example, all the physical laws and everything embedded within that brain. So if the atoms came together with and formed a brain which has all the memories, which has all the identities, then you can ask one question: how is it actually different from what I am experiencing right now? So it turns out there's no difference, because what is happening is there's a human right now, there's a human being sitting here. I have some memories, I have some identities, and there are some physical laws that are applicable to me. And there is also this human brain that has spontaneously manifested in this universe, which also has the exact same memories, the exact same identities, the exact same experiences as that of this human being. So then technically there's no difference between a human being and a brain spontaneously manifesting in this universe. So this idea had a lot of physicists worried, and it turns out, if you have infinite time, if you assume that the universe is of infinite length, it turns out the probability that that a Boltzmann brain like this, a spontaneous brain coming up, is much, much, much higher than for the human to have undergone evolution completely and come to the point where a human being actually is. So it turns out, if you give an infinite lifetime for the universe, we might all technically be just these kind of Boltzmann brains, and not really a human who has evolved throughout for millennia, and finally come to the stage where human being is. So it's a fun thing to think about. Like, we could actually be these kind of Boltzmann brains that are just manifesting because of atoms coming together through some fluctuations, and not really who we think we are. Yeah. So, but then again, I want to include some caveats here. It turns out that, well, according to physicists at least, that the universe is not infinite in time. We have a specific number of years. So the age of the universe is 13 billion years old, is what we predict right now. And so a Boltzmann brain might not be there. And then again, this is assuming that we are living in a universe where we have thought of these things. But if you think about it, a Boltzmann brain, it could be a Boltzmann brain in reality, which is lingering in infinite time. We just thought of that concept also. So we don't know about it, and but then like, physicists have put a lot of numbers, which I'm not going to delve into, and there are all of these competing theories as well, which says that the Boltzmann brain doesn't really exist, and so on. But what I want to take away from this talk is not about whether a Boltzmann brain exists, or are we really some kind of Boltzmann brains? Do we take this for granted? But what I want to emphasize over here is, now that you can play around with all of these things, and you actually end up with these kind of results from a very fundamental notion of what we understand from the universe. So thermodynamics and statistical physics, like I mentioned, are very fundamental understandings of the physics of this universe. So just playing around with these fundamental principles, you come out with such kind of deep such kind of deep intricacies, and which has made scientists even today think a lot on these kind of concepts. So one thing you can really ask now is how much of this basic fundamental properties of the universe do we really know? Because something as fundamental as thermodynamics and something as fundamental as statistical mechanics is actually giving rise to all of these different possibilities of how the universe is. Given that it is giving out so many possibilities, and there is a small chance that we are actually these kind of Boltzmann brains, how much of the basic understanding do we really have, and how much of our understanding is really true? Because now we are essentially questioning things on a very fundamental level. So how much of this universe do we really know, and how much of that is reality, and how much of that is the truth, or how much of that is some kind of a false understanding, like what we just explained, like we could really be Boltzmann brains, and not really some human form that has come through millennia of evolution. So we don't know a lot of things about the universe, and this is the real question of what is real and what is illusion. How much of this real universe do we really know? This is the most fundamental question, and you can really say that the universe indeed works in some mysterious ways. Thanks. Any questions?
Yeah, can you stop sharing?
Yes.
Very interesting, Pranav.
Uh-huh.
So, is there only one Boltzmann brain in which whole universe is appearing, or multiple Boltzmann brains?
You just need one Boltzmann brain, because finally it is just one. Like the way I am understanding universe is through my experiences, my notions. So you just really need one Boltzmann brain for that.
So actually, it's like saying the whole universe lives in one brain.
Yes.
Right, where all the living beings, it's like a big supercomputer which is simulating a lot of
it's like that Matrix movie. Yes. Yes.
Okay, so now there's a theory in science. I mean, some of the modern day computer science, they're saying we are living in a simulated world like Matrix.
Yeah.
So in then Vedanta, there is a Vedanta or spirituality. In philosophy, there's one called solipsism. Means there's only one soul is there.
Yes.
All of these are in that one virtual reality where we are living. Can we ever find out what is reality from this virtual reality? That question, who is anybody has addressed?
I guess so. For me, the question comes back to the same old thing. What is reality?
Okay, what is reality?
So, so I guess in a deep sense, all of them are looking for some sort of reality, and for a person, I guess, in a deep sense, reality is something that doesn't change.
Right.
So then I'll address this question in a different way. Is there something which never changes?
Yes.
And so we are looking for that. So for example, in physics, we have these physics laws, and the reason why they are called laws, the reason why they are called laws, is that we assume things never change. Gravity, for example, we have gravitational laws, and gravity is supposed to work this way, and that is the way gravity works.
Right.
And that is why it's a law. So what we are essentially looking for is something concrete in the universe, something that doesn't change. Now, now can you ever prove that something never changes? I don't know about that. Because if you ever want to prove that something never changes, you'll have to observe it for an infinite time. Then only you can conclude and say it doesn't change. For example, if gravity,
or you have to prove the time is not there.
yeah, or prove that time is not there, sure. But then again, like, yeah, you can prove that time is not there. But then again, this concept of change is assuming that it's changing with time. So let's say there's something that's not changing with just space. Let's say there's some way where we can just talk space separately and talk time separately. And let's say we are living in a universe where there's no time, but we understand the concept of space. Then also we'll have to observe infinite space in order to understand that something doesn't change.
Space
So
also
in
doesn't
order to, sorry?
Space also doesn't exist. Time also doesn't exist. Space doesn't exist.
Yeah, so then if you are just eliminating everything doesn't exist, then life becomes simple. There's nothing to observe and say there's no change also.
Okay. For all
So,
you know, this concept of change or unchange and all, maybe a concept in the Boltzmann's brain, no?
sure, yeah, why not?
Boltzmann brain is dreaming that there's so many things are there.
Yeah, it could be. Yeah, but then again, like I said, this Boltzmann brain it's a very nice theory, but it has a lot of caveats to it, which I haven't mentioned. Like, for one of the most fundamental thing is that, so like I said, like a broken glass spontaneously becoming a normal glass itself takes a very long time. So for things to randomly come and form this kind of a Boltzmann brain, they've actually given numbers to it. So it turns out that the number is astronomically huge. It's like 10 to the 10 to the 50. So
But universe doesn't care about time, no? It's eternity.
so that's the point. So so as of now, the majority, the theory is that I mean, the most well-known theory of the universe is this Big Bang theory. And according to the Big Bang theory, the age of the universe, we can predict the age of the universe. So it's 13 billion years. That number is nowhere close to this Boltzmann brain forming. So that is one way we reconcile things.
So
But then if you assume, sorry?
Big Bang theory, there's another this thing, right? The Penrose. Penrose says universe itself, Big Bang is not the beginning. Before that, the universe were there, they collapse, and again it's like a cyclic.
Yes. So there are these cyclic theory, bouncing universe theory. So even if you include those theories, people have come up with explanations where Boltzmann brain need not be there as well. There are some competing theories and stuff. So I haven't gone into those things, but yeah, I mean, this is a very nice idea of thinking about things, and it's coming from physics in the sense that you can start putting numbers now.
Okay.
So yeah.
So coming to second law of thermodynamics.
Yes.
Or entropy will keep on increasing, or randomness will keep on increasing, right?
Yes.
So randomness will keep on increasing as long as there's no intelligence to put them together.
So,
for example, a glass.
What do you mean by that?
A glass is broken, right?
Yes.
Okay. Now I have intelligence. I'll come put in some glue and make it again this thing. So an intelligent being can give order in the order where this randomness is there. Intelligence can operate against randomness.
So you can create local, so for example, you can create local order in things, and that is how life works. So for example, if you want to extract any useful work, you have to create some order. Like for example, in order to run a bike, let's say you need fuel. So you need to extract fuel from the bottom of the earth, refine it, add oil, put it into this engine. The engine has to work in a very certain way. And that is the way you can actually extract work and ride the bike, right?
Mm-hmm.
So you can create local order like this. But if you actually look at the total randomness that you have created in the universe, It's
Mhm.
always increasing. So you can create local puddles of order like this, but the total randomness is always going to increase.
So basically, universe is nothing but chaotic.
Chaotic, I don't know. How do you
Randomness,
define
randomness
chaos?
is chaos.
Okay. Like in physics, chaos is like a very specific thing.
Okay.
So the thing is, these are all so chaos is a probabilistic thing, but it is it is deterministic. Like
Okay.
it's so like classical physics in general is going to be, so all of these are probabilistic, but you can still say some things about it. Now, quantum mechanics is a true probabilistic theory where there is no determinism at all over there.
Okay.
So, so in that way, yeah, sure. I guess you can call it chaotic, like in that randomness. Yeah.
So I can say that I can create a local order. So I'll
Yes.
say the universal order is also there. That's what is creating this universe. That's called infinite intelligence is creating this universe from chaos. So do you have counter to that?
Infinite intelligence is creating chaos. So
No, infinite intelligence is showing order in the chaos. I have laws, gravitation laws, infinite intelligence, we can call this God or infinite intelligence. So that is the one who is creating this order in this whole thing. Because we can see atomic order, galactic order, everything is there. So the order is created out of chaos or randomness by infinite intelligence. Just like I have local intelligence, I can do something. Infinite intelligence is doing something.
okay, what do you call infinite intelligence? How are you defining intelligence?
So I would define intelligence as randomness is the law of nature. Okay. To create or show order in that randomness. Intelligence.
Okay, so you are saying there is randomness throughout, but there is some, okay, fine. I mean, I don't know how to put these things into physics perspective, but you're saying that there is some intelligence which creates local order everywhere.
Local and global order also, universal order also.
Okay, fine.
Okay, so that's why even though given second law of thermodynamics, universe should be supposed to be random and disintegrating, which is actually happpening. But again, the order will be built there because of the intelligence.
No, so that's what I said. So the total order, so the total randomness is always increasing. So that's why I said, like, for example, you created some local order. The thing is, the amount of local order you have created, the randomness that has gone into the universe, the global universe is higher than that. So if you take the sum total, let's say you created some order, so you removed some quantity. So the quantity that we define over here, so we have some, so the way we define this is called entropy. So yes, so entropy is a measure of randomness. So now let's say you created some local order. So you decrease the entropy over there. You remove some entropy. But corresponding to this very same action, what I've also done, you have increased the entropy. When you are decreasing the entropy, you have also increased the entropy of everything else other than that local region.
Okay.
Now, if you add these two, like, so you have removed some, you have added some. Now, if you add these two, that number is always going to be higher than what you started with.
Okay.
So this is how we say that the entropy of the universe is always increasing.
Physics don't have a place for intelligence.
Yes. Not only that.
That's what you're saying. You're ruling out any intelligence in the universe.
I'm not saying I'm not. That's why I don't understand what this intelligence is. So we measure randomness through this thing called entropy. Now, yeah. So this entropy is actually a measure of information as well.
Correct.
So you can so there are multiple ways of understanding entropy, and this may be, so entropy is actually you can think of it as information as well. So in that way, information, like the amount of, let's say, gross information that is available to understand in the universe is always increasing.
Okay,
So
so
that's
question is
why
that
randomness is increasing. Sorry.
no. To understand the universe, when you understand it becomes information, right? Let's say you create you understand that whole gravitational force, that becomes information. Is it correct?
So I don't know how to tie that. I don't know how to tie that up with this concept of entropy, because like understanding something is different from a definition of what we have as entropy.
Okay.
So all I can say from physics point of view is that the entropy, which is defined in a very specific way, is increasing.
Okay.
Now somebody else could come and give and say we have a more robust definition of what intelligence is, define it so and so way, and then he can actually say that okay, the intelligence of this universe is actually decreasing or whatever. Yeah.
Okay.
So
Thanks.
Pranav, there is an argument that what we call universe is a set of laws which have been so tightly bound, so intelligently created, that there is a specific way of the way this whole creation has happened, or the way an atom is formed, or a quark is formed, or anything that we are now discussing. In fact, the way how the Big Bang's various stages have gone through, there have been laws which have been intelligently changed. They were existing laws and there are new laws, and these laws have been framed very intelligently in such a way that this whole universe, matter, and the whole universe as we see now is made possible. So that there is this notion of intelligence already that a lot of scientists are looking at. Now, it is true that entropy works in universe, but essentially what you're saying is, in order to make this universe, this intelligence has to be outside the universe itself, because we are talking of a force which is making these laws which are now prevalent in the universe. Correct?
I don't know about that. I don't know about that.
Logically, if you look at it, is it not true that
there's
a universe like this, with a precise laws like this, which by the chance of the law being like that, for example, the universal constants, if they are a little bit here and there, then we won't have the universe that we had today. Correct?
Yes.
Let's know that, right? So
that's
who
true.
made those universal constants in this particular universe in that fashion is an act of intelligence, is what some scientists consider. Is it right or wrong?
Okay,
correct?
Fine. No. Okay, wait.
Huh?
So there is something called as this anthropic principle, where there is this bias. So I'll give you an example. So let's say, so I gave typewriters to monkeys. Okay, so monkeys don't know how to make intelligent sentences. Okay, so let's say monkey. There are like thousands of monkeys, and thousands of monkeys have started typing randomly. Now let's say each of these random things has some sort of, each of these words that are being typed has some sort of sentience, let's say. So let's say the more sentences start making sense, the more sentient the letter become, the paragraph becomes. So each monkey is typing away. Most of the time it's all junk. So it's like it just types something randomly on the keyboard, like QWERTY, whatever, and it doesn't make any sense. So the sentient of, so then let's say the sentience of that particular thing that you have typed is very, very low. But ever so rarely, just once, like if you gave these monkeys a lifetime to work around, once there is a chance that it will print a very nice print a very nice statement, a nice paragraph, right? So then this paragraph has become sentient now. So this paragraph understands things, and this paragraph looks at all the other things these monkeys have typed. Of course, it can't understand the monkey itself, but it can understand the words that has been typed, and it looks around and says, now this thing has become sentient. And then this thing starts saying, I have become sentient. So if I exist, things like me should exist in other places as well. But it looks around, and it sees that there is not there's no sentience. And then it says,
this
and
argument
then
is also, this argument is similar to saying, some people say, some scientists say, that there have been multiple universes in which there were multiple sets of universal constants, but it so happened only in this universe, the universal constants fell in line in such a way that this universe was made possible. I agree with that. I mean, that is how multiple universes, multiple unfructuous universes came, of which only one in millions and millions and billions random universe really became what we see, which is orderly. I understand this also. Very good. But you go one step ahead in that. Who made possible? So now you're talking of monkeys and typewriters. Somebody made monkeys and typewriters for this experiment. Now, who made possible for multiple such universes and laws and
fine.
Now again, intelligence will come up again there, right?
Okay, fine. So then you can, let me just stop this. So again, you can just say, so this argument is repetitive, right? You can say, who made the monkeys? Then you'll ask, who made the person who made the monkeys? And you can go on and go. So the idea, so for me at least, the idea is not to spend on not to spend my precious time on these kind of theories.
So as a scientist, you want to work within the universal laws, be in the universe, and look at the universe.
As a scientist,
what monkeys have done, not monkeys itself.
Yes. As a scientist, for me, I guess what I want to do is, okay, if I am in a particular state right now, there is something happening around me. Like I said in the monkeys case, right? It's all of these thousands of monkeys typing things at random, and suddenly it created something, and suddenly we think that we are something special. Like the paragraph has thought that it's something special, and it's come out of, and it feels like, okay, there is a reason for its existence. There is a reason for why the paragraph is there. It thinks I am special. This particular universe is special, so there must be something behind it, and so on and so forth. Instead, if you just think about this whole example, all that has happened is something that is completely random. And it just came out of chance, and it will go away in chance also.
So the question of random and chance, we are taking for granted, right? Random and chance are all time related. Time exists only in the universe. Correct?
So I am saying instead of spending time in trying to understand what made us, is there something special about this particular universe? Things have, if you change these fundamental constants that we have by even one tiny minute decimal digit, human life actually wouldn't exist. An atom wouldn't exist. So instead of thinking and pondering over why exactly this has happened, is there some intelligent being operating? Instead, what we can actually do is we can actually understand, just try to understand, okay, this is just the way the universe is. This is the way it is happening. This is the way things are going on, and it might continue in some other different way. Just like just remove the specialty part of things. Just try to understand, just understand that, okay, this is the way this current universe works. And if there is some
So
other way,
what you
if
are
there are
saying
some
is
alien
there's
forms.
no meaning in scientists looking at this Boltzmann brain, which is exactly what you're saying, correct? You are looking at how atoms can have a form, a random thing to make a Boltzmann brain itself is what you're saying. It is a useless exercise. But still, it is being looked at because we want to understand the very law of physics, and the zeal of physics
Yes.
is to know the reality, right?
Yes, that's right. Yeah,
Yeah.
so you want to know the reality. Instead of looking over there, maybe you can look at some other place.
No, see, it is a when we tried to look into reality only, we knew these constants were very fixed, right? So if you want to understand reality, you have to understand what made those laws and how, correct? So is it not a right path? Because this is what is now leading scientists to look at consciousness. And there are a lot of people who are now trying to look at consciousness as something outside the universe, which is up to now people who are not willing to accept.
Okay.
Correct?
So,
and in
yeah,
fact,
so
that brings back to Socrates' first statement or Pluto's first statement. We are only looking within the universe. Pluto's cave is nothing but the universe.
yeah,
Correct?
so
But the light for the universe is coming outside the cave.
So again, yeah, so for me, then this argument is like, so this is one argument why scientists use and say why God doesn't exist. because they say if there is a creator for this universe,
then I'll ask the
there
same
must be
question. What is God by scientists? Before you say God doesn't exist, they have to define what is God, no? What is
so
God?
for them, so for them, God is a creator. So if this universe has a creator, then that creator should have a creator, and that creator should have a creator.
They say there's no intelligence. What scientists say, there is no intelligence.
No, so that's not what scientists say. So
no, I'm saying God is intelligence. You're saying there is no higher intelligence. That means there is no God.
No, so why are you classifying intelligence into different things? Why do you say this is less intelligent, this is more intelligent? If there's only one intelligence, then there's nothing to prove, right?
Correct, but the whole science is based on...
So then this hierarchy itself doesn't exist. So
if there is based on intelligence, right? If there's no intelligence, there's no science, correct?
So if you say, so that's what I'm saying. So if you say everything is intelligent, then there is no reason for you to have this creator and created thing.
Yeah.
So okay. you are saying this universe exists in one particular way, that the fundamental constants are designed at some particular way. So there must be some creator behind it. So by definition, you have already...
There's some intelligence.
Okay, fine.
Is a different thing. Intelligence.
Okay, fine. I'll use your word, intelligence. So you are saying there must be some intelligence behind it. Then by that definition, you have already said that there is some intelligence which is bigger, which is capable. For example, if I ask my phone to build another phone, it won't be able to do it. But if I ask a human to build a phone, it will be able to do it. Which means at some stage you are assuming that there is some intelligence which is bigger than what exists, and only that particular intelligence is capable of creating. Now, if you go on this loop, you can always find some bigger intelligence. So that by definition you can rule out, because that is a never-ending process. Instead, if you don't give any weight to intelligence and just say all there is just intelligence, like even an atom, even an electron, there's so much intelligence in it, right? There's what and all scientists do to constrain an electron. Like recently, this Nobel Prize was won for imaging an electron, and they had to do so much work to create those light pulses and stuff. So it's like an electron is like, I won't show you what my real form is. You have to do all of these things, and then and then find out what I am.
Is artificial intelligence, and what you think humans are is artificial intelligence for some other intelligence, isn't it? We are just artificially made intelligent by some other intelligence. If
Yeah,
we assume that intelligence, then this hierarchy of intelligence works. Correct?
yeah, but then you can
You
keep
now,
asking
you
that.
now say humans' intelligence reflected somewhere is artificial intelligence. So
Sure,
even our
fine.
intelligence is reflected from some other intelligence, isn't it?
Sure, you can do that. All I'm saying is that's a never. All I'm saying is logically to me that's a never-ending loop,
No,
because to some
it ends beyond the universe.
fine there
All
can be something.
physics is within the universe.
Okay.
Then, in order to explain this universe, you have to go beyond the universe.
I'll say in simple words, Pranav. What he's saying is, go back to Plato's cave. So all scientific discoveries in the shadows, not in the reality. There's the question. Is that correct? Answer.
Sorry.
All inference. We are in a Plato's cave. We are in a
Okay.
cave. And all our scientific discovery, everything is in the shadows, about
Okay.
shadows, and it's never about light. Is that correct understanding of science?
No, so that's so what science tries to do is science tries to find what exactly is this real. So science has one direction, which is to probe what is so-called reality.
Right. So in the Plato's cave analogy, understanding the shadows better is the reality.
No, it's not, because science always, so for example, I would say a better example for that would be like this blind man elephant theory. There's an elephant, and the blind man is trying to understand what the elephant is, and we are probing different things. Now, if you want to truly understand the elephant, you need to probe the elephant in infinite ways.
Correct.
Which is what science does. So it takes
anyway,
the shadow.
As I should come back and say, infinite ways is not possible because it's infinite.
Yes.
You'll never be able to find the elephant. That's what it says.
Yes. So science will reach at some point there. It's just that some of us are a little too eager to conclude. So we'll just look at the trunk and we'll say, this is how the elephant is.
Okay. So one more question. Okay. So in a given dimension, let's say we are dimension being, we'll never be able to understand what's happening in the fourth dimension. So higher the dimension, the lower level being is the lower level dimension, will never be able to understand the higher level being dimensions. Is it true?
So it depends on what your definition of dimension is. If your dimension is space, for example,
string theory says there are 10 dimensions.
Yes.
We are right now operating and thinking in the dimension, maybe lower 2 dimensions. I don't know. So that higher and higher dimensions are only mathematically we can say something, but we'll never be able to understand it.
Yeah. So again, there and string theory, those 10 dimensions are very specific. It's actually spatial dimensions and a time dimension. So it is actually like 8 or 9. I don't know how many spatial dimensions. I don't know string theory, but it's like 8 or 9 spatial dimensions, I guess. So it's actually a spatial dimension. And then the way and then okay, fine. So then so more than 3 spatial dimensions, let's say. So then the way they try to understand it is they say I don't want to get into details, but they say that these dimensions are essentially like coiled, and they are at a very small length scale, which really doesn't matter to us. So when the universe started, right at the Big Bang, just after the Big Bang, the universe was 10 dimensional of space. So it was 10 dimensions of space. So then the dimensions actually got reduced and reduced and reduced, and now we are 3 dimensions. Don't know, someday the universe might become 2 dimensional.
Okay.
So that way, yeah. So that is the nature. Like that is the nature of this. So there, it's actually physical spatial dimension. So yes, true. We are 3-dimensional beings, so we can't imagine a 4th spatial dimension. But yeah, we can conceive ideas about it. We can talk about it, how it might look, and things like that.
Okay, Pranav. Thank you. It's so wonderful.
Yeah, excellent, Pranav. This, very deep thought. Any questions from anybody else? Neeraj, Komani, Geeta?
Anybody from Zoom? Any
from
questions?
Zoom? Yeah. Okay, so we don't seem to have any more questions. So, Prabhuji, any final comments?
No. I'm not really sure what we are trying to look at. I mean, am I in the Boltzmann brain, or the whole thing is as Pranav started, he's not going to conclude. So I'm trying to find out whether I'm in a brain or I have a brain. I don't know.
All he says is we are one of the random arrangements.
Yes.
And he wants to end at that. So randomness is when it includes a lot of other things. We are one of many. That's all.
Many. Okay.
Excellent topic, Pranav, and really, very mind and sometimes soul stirring also. So thanks for this talk. Thank you a lot.
So sometime we would like to speak on the parallel universes and multiple universes also.
Yes.
Yeah, I can talk about that. Yeah.
Can you help us to travel to other universes?
Okay.
So you told about Matrix movie, and that Matrix movie, Neo is able to break through the Matrix movie. So
Yes.
Can scientists help us to get out of this Matrix? What you're saying?
You should tell me what the red pill is over here.
What is it? Red
What
pill.
is the red pill?
We were hoping you can give us some red pill. That's what I'm trying to see.
Okay.
All that also, we are breaking our head to find the blue pill. Where is this? Okay. So, Hari Om. Thank you, Pranav.
Thank you.
Thanks for the wonderful this thing. Let me know if you can speak sometime on the parallel universes and multiple universes
Yes.
also.
Sure.
Namaste.